When the interstellar visitor known as 3I Atlas first arrived in our solar system, it already bore the promise of mystery. Discovered on 1 July 2025 by the Asteroid Terrestrial Impact Last Alert System (ATLAS) survey in Chile, the object was quickly confirmed as the third known interstellar object, the 3I marking, ever detected passing through our Sun's neighborhood. The Economic Times. Unlike familiar comets born in our own solar system, 3I Atlas arrived on a hyperbolic trajectory that will carry it out of our solar system again, making it a rare and priceless chance to study material born around another star. Wikipedia. What has scientists especially intrigued is the way 3I Atlas is behaving. It's not just passing by quietly, but showing signs of unexpected activity and composition that challenge our assumptions about comets and interstellar wanderers. Multiple telescopes, including ground-based observatories and space assets, have captured its changing coma, the enveloping cloud of gas and dust, its emerging tail, and a dramatic jet of material shooting toward the Sun. For example, images from the International Gemini Observatory and the 2-meter twin telescope captured on 2 August show a distinctive sun-facing jet of dust and gas emanating from 3I Atlas's nucleus region. Moreover, when the James Webb Space Telescope, JWST, turned its spectrograph instruments toward 3I Atlas on 6 August 2025, a startling result emerged. The coma was dominated by carbon dioxide, CO2, relative to water, H2O, in a ratio of about 8.1, among the highest ever seen in any comet, RC. Such a high CO2-H2O ratio suggests that 3I Atlas either formed in a very different environment, for instance, near the CO2 ice line in a protoplanetary disk of another star, or was exposed to hard radiation that changed its surface chemistry over billions of years. The composition hints at ice and dust chemistry unlike typical solar system comets. What's more, photometric observations from the Atlas network recorded a significant evolution in 3I Atlas's brightness and color, from a redder hue early on to a more neutral solar color as its coma evolved and a tail developed. Archive. Polarimetric observations using the Very Large Telescope and other large facilities showed an extreme negative polarization branch in its light-scattering behavior. That is, it behaved in ways not seen in previously studied comets or asteroids, but more like some distant trans-Neptunian objects or centaurs. Archive. All these signs point to 3I Atlas not simply being a run-of-the-mill comet, but rather a visitor rich in exotic properties and with a highly unusual history. The darkening or changing behavior of 3I Atlas is part of that story. As it nears its closest approach to the Sun, perihelion on 29 to 30th October 2025, it is undergoing dramatic transformation. Jets of volatile gas, dust outflow, shifting coma geometry, tail growth, and evolving optical properties all combine to create a rapidly changing object. Observatories tracking it report that its cross-sectional coma area is decreasing in rate, interpreted as darkening in some filters, even as dust and ice are being ejected. Archive. It's as though the surface of 3 Atlas is rapidly being altered, perhaps shedding older irradiated material, exposing fresher ices, or simply being reshaped by solar heating in a way we don't yet fully understand. Why does all this matter? Because 3I Atlas gives us a rare window into materials and processes from beyond our solar system. If we only ever studied comets formed around our sun, we'd miss a huge part of cosmic diversity. With 3I Atlas, we have the chance to ask, what do comet-like bodies look like around other stars? How are they formed? How long do they survive? And how do they change when they enter another star's domain, experiencing a radically different thermal and radiation environment? The evolving darkening of their coma or surface reminds us that these are dynamic, living objects, not relics frozen in time. Furthermore, the rapid changes observed in 3I Atlas highlight the importance of quick, coordinated observations across multiple telescopes and wavelengths, from the Gemini Earth-based observatories to the Mars-orbiting assets of the ExoMars Trace Gas Orbiter, which snapped the closest images yet when the comet passed near. Mars on 3rd October 2025 at 2:10 Nuntal's km/h. Every data point counts. Live science. These campaigns allow scientists to capture how the comet's dust and gas respond in real time to solar heating, how jets form and evolve, how tail formation begins, and thereby test cometary physics under extreme, unfamiliar conditions. In essence, the phenomenon of 3I Atlas's darkening, tail growth, high CO2 chemistry, and unusual polarization all combine into a story of cosmic surprise. We are watching an interstellar wanderer not just cross our solar system, but visibly transform before our eyes, a visitor shaped in another star system, now briefly exposed to the full power of our sun. This moment, fleeting as it is, may provide the clues that unlock how planetary systems form and disperse, how small icy bodies live and die, and how our solar system compares to the billions of others in the galaxy. To summarize, 3I Atlas is more than just an exotic curiosity. It is a messenger from elsewhere, whispering secrets about the wider universe. Its darkening behavior, rapid changes, unconventional chemistry, and astonishing activity challenge our cometary models and expand our conception of what interstellar visitors can be. As it swings past the sun and exits our system, it will leave behind a legacy of data, questions, and wonder. And for the first time, humans are not just observing interstellar objects. We are tracking them from discovery through transformation. The story of 3I Atlas is far from over.